Let's go to guided practice 3. Consider phi equals a plus bi to the third power, where a, b are real numbers. In terms of a and b, find the real part of phi. Try to remember Pascal's triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So for a plus b to the third power, we will get 1 plus 3 plus 3 plus 1. A to the third power, a squared, a to the 0 power. Then b to the 0 power, b to the first power, b squared, b to the third power. Organize. Equals a to the third power plus 3a squared b plus 3ab squared plus b to the third power. Check the exponents. The sum of the exponents for each term should be 3. 3. 2 plus 1 is 3. 1 plus 2 is 3. 3. Then we will put a equals a and b equals bi. We will get a plus bi to the third power equals a to the third power plus 3a squared times bi plus 3a times bi squared plus bi to the third power. Remember, I to the 0 power equals 1. I to the first power equals I squared equals -1. I to the third power equals I squared times I equals -I. Organize a to the third power plus 3a squared bi. This is b squared I squared, which is -b squared. So we get minus 3ab squared. For this term, b to the third power times I to the third power, which is b to the third power times -I. So we get negative b to the third power I. Put a real number together, a to the third power minus 3ab squared plus 3a squared b minus b to the third power I. The real part of phi. This is the symbol. Equals a to the third power minus 3ab squared. Imaginary part of phi equals 3a squared b minus b to the third power. Let's go to b. Hence or otherwise. Hence means try to use the conclusion in previous questions. Show that 1 plus the square root of 3i to the third power equals -8. A equals 1, b equals the square root of 3. For real part of phi equals 1 to the third power minus 3 times 1 times the square root of 3 squared equals 1 minus 9 equals -8. Imaginary part of phi equals 3 times 1 squared times the square root of 3 minus square root of 3 to the third power. Organize 3 square root of 3 minus square root of 3 to the third power equals square root of 3 squared times the square root of 3. So we get 3 square root of 3 equals 0. So 1 plus square root of 3i to the third power equals negative 8. The roots of equation z to the third power equals negative 8 are u, v, and w, where u equals 1 plus square root of 3i, and v is all real numbers. Write down v and w, giving your answers in Cartesian form. We can figure out this v easily. Z to the third power equals negative 8. So z equals cubic root of negative 8 equals negative 2. So v equals negative 2. And u equals 1 plus square root of 3i. Now let's work out this w. Z to the third power plus 8 equals 0. Let's use this formula to work out w. A sub n equals 1. A sub n minus 1 equals 0. So u plus v plus w equals negative 0 over 1 equals 0. Do the substitution. 1 plus square root of 3i minus 2 plus w equals 0. Combine like terms. Negative 1 plus square root of 3i plus w equals 0. So w equals 1 minus square root of 3i. Therefore, v equals negative 2. W equals 1 minus square root of 3i. On an Argand diagram, u, v, and w are represented by the points u, v, and w respectively. Find the area of the triangle UVW. Let's use the Argand diagram to show UVW. This is negative 2. 1 plus square root of 3i. 1 plus square root of 3, estimate here. 1 minus square root of 3i. Then connect these 3 points to form triangle. This is a V. Here is U. This is a W. We know the roots will form a regular polygon. This is 60 degrees. And the base equals 2 square root of 3. The height is 3. So area of triangle UVW equals 1/2 times 2 square root of 3 times 3 equals 3 square root of 3. Let's go to E. Each of the points U, V, and W is rotated counterclockwise about 0 through an angle of pi over 4 to form the 3 new points U prime, V prime, and W prime. Rotated counterclockwise means times e to the power of pi over 4i. These points represent the complex number u prime, v prime, and w prime respectively. Find u prime, v prime, and w prime give your answer in this form, Euler form. Theta is greater than negative pi, less than or equal to pi. We know u equals 1 plus square root of 3i, and v equals negative 2. W equals 1 minus square root of 3i. We need to change these three roots into Euler form. R equals square root 1 squared plus square root of 3 squared equals 2. So take a 2 out. 1 over 2 plus square root of 3 over 2i. In the first quadrant, and square root of 3 over 2 corresponding reference angle alpha equals 60 degrees, which is pi over 3. So we get 2 times e to the power of pi over 3i. V equals negative 2. Go to arcane diagram. Negative 2 is here. Argument theta equals pi. So we get 2 times e to the power of pi I. For this w, we get 2 times 1 over 2 minus the square root of 3 over 2i. Reference angle based on this imaginary part, we got alpha equals pi over 3. 1/2 minus the square root of 3 over 2i. Reference angle is pi over 3. Go to the fourth quadrant. This is 1 over 2. Negative square root of 3 over 2. Go to the fourth quadrant. In the fourth quadrant, the argument will be 5 pi over 3. So we get 2 times e to the power of 5 pi over 3i. Therefore, for u prime equals 2 times e to the power of pi over 3i times e to the power of pi over 4i. We got 2 times e to the power of 7 pi over 12i. For v prime equals 2 times e to the power of pi I times e to the power of pi over 4i. Add the exponents together 2 times e to the power of 5 pi over 4i. For w prime equals 2 times e to the power of 5 pi over 3i times e to the power of pi over 4i equals 2 times e to the power of 5 pi over 3 plus pi over 4. We will get times 4 times 4. 20 pi over 12 plus 3 pi over 12, which is 23 pi over 12. 23 pi over 12i. Let's go to F. Given that u prime, v prime, and w prime are the solution of z to the third power equals c plus di, where c, d are real numbers, find the value of c and the value of d. Remember, whenever we are dealing with roots, we got to use sum and product of the roots of polynomial equations. Z to the third power minus c minus di equals 0. You have to change complex equation into equal to 0 form. Then a sub n equals 1. A sub n minus 1 equals 0. A sub 0 equals negative c minus di. So we get u prime plus v prime plus w prime equals 0. And u prime times v prime times w prime equals negative 1 to the third power times negative c minus di over 1. Simplify c plus di. Since we are looking for c and d, we got to use this equation. So we get 2 times e to the power of 7 pi over 12i times 2 times e to the power of 5 pi over 4i times 2 times e to the power of 23 pi over 12i equals c plus di. Organize 8 times e to the power of 7 pi over 12 plus 5 pi over 4 plus 23 pi over 12 equals, denominator is 12. 7 pi plus 23 pi is 30 pi plus times 3 times 3, 15 pi. So we get 45 pi over 12 reduce 15 pi over 4. So we get 8 times e to the power of 15 pi over 4i equals c plus di. 15 pi over 4 minus even pi. So we get the same terminal side. 2 pi equals 7 pi over 4. 8 times e to the power of 7 pi over 4i equals c plus di. Let's go to Argand diagram. 7 pi over 4 go to the fourth quadrant. Reference angle is pi over 4, which is 45 degrees. Square root of 2 over 2. Negative square root of 2 over 2. So we get 8 times square root of 2 over 2 minus square root of 2 over 2i equals c plus di. Distributive property. 4 square root of 2 minus 4 square root of 2i equals c plus di. So c equals 4 square root of 2. D equals negative 4 square root of 2. Let's go to D. It's given that u, v, w, u prime, v prime, and w prime are all solutions of z to the nth power equals alpha. For some alpha, it's all complex numbers, where n is natural numbers. Find the smallest positive value of n. We will use this fact to work out this n. First of all, let's figure out the argument of each root. So the argument of u equals 60 degrees. Argument of v is 180 degrees. argument of w 5 pi over 3 equals 5 times 180. We will change pi into 180 degree. 5 times 180 degree over 3 equals 300 degree. The argument of u prime equals 7 times 180 degree over 12 reduce equals 105 degree. The argument of v prime equals 5 times 180 degree over 4 reduce equals 225 degree. The argument of w prime equals 23 times 180 degree over 12 equals 345 degree. Now list all these arguments from smallest to the largest degree. 60 degree, 105 degree, 180 degree, 225 degree, 300 degree, 345 degree. We got to use these facts. Each subsequent root is obtained by rotating counterclockwise by 2 pi over n. In other words, the angle between two subsequent roots will be 2 pi over n. So let's work out the difference between two angles here. 45 degree, 75 degree, 45 degree, 75 degree, 45 degree. So the greatest common factor of 45 degree and 75 degree is 15 degree. Therefore, 2 pi over n equals 360 degree over n equals 15 degree. N equals 360 degree over 15 degree equals 24. The smallest value of n is 24.